You should see on your screen the slide presentation that Chance has shared on the screen there. So welcome everybody. Welcome back to school. I trust that everybody's kind of getting back into just kind of the routine, or maybe you're just starting back tomorrow. I know some schools are starting back Wednesday. Anyway, welcome to 2026. So here we go. This session is called Integrating Math and Computer Science. And I am Jeremy Maker. I'm the project director of computer science education for the State Department of Education. And on the screen, you'll see a Facebook group called OK Comp Sci Facebook. And that is a link. We'll share these slides out later, but you can also jot that down. I would encourage all of you to join that Facebook group. It's not run by the State Department of Education. It's run by educators, but we do often post different announcements, opportunities, trainings, just a whole lot of different things to that Facebook group. So that's a good place to kind of find out information. And then one of our favorite things to do is to collaborate with educators. And so you have my email address there, and I try to be really responsive to that. If you ever have any questions, or you need a thought partner, or so you have ideas that you think other educators should have, something went really well in your classroom, please send me an email. And we will try to share that out as best as we are able to. And so I'll hand it over for Chance for just a minute.
Yes, my name's Chance Stone. I'm the project manager of mathematics. Am I back? Can you hear me now? No. Can you? Yes?
I can hear you.
Okay. Excellent.
Yeah,
my name is Okay, perfect. My name is Chance Stone. I'm in the Office of Standards and Learning as the project manager of mathematics. You also have
Now you're gone.
At the bottom there, I think Jeremy might still think I'm muted, so something might be different for his audio experience than the rest of us.
We'll kind of pivot there. We'll see if he can. Chance, if you get it figured out, just
Jeremy, we can hear you.
If I hear your voice, then I'll just hand it right over to you.
Jeremy, can you hear me?
Can everybody hear Chance? Am I the only one that can't? Oh my gosh. Okay, Chance, you go ahead.
Okay, so yeah, I sent a little chat message to him. But my name is Chance Stone, Office of Standards and Learning, Project Manager of Mathematics for PK-12 Education. With my contact information, definitely use it just as you would use for practice with Jeremy. I'm open to the insights that educators are engaging with their students, how they're engaging in instructional practices in their classroom to hopefully lean on those, maybe enhance our Oklahoma math frameworks to the best of our ability. I think in the future, I would love to see enhancements made to suggesting specific intervention practices. So if you're using interventions in your classroom that you want to share more information with me about, I would love to hear those specifically. And any updates to any standards or objectives that you would like enhanced in the coming years. We have our standards revision process beginning in 2027. So I'm always willing to learn and hear more about specific educators' experiences as it relates to standards and objectives in mathematics. But we will continue today's session with Jeremy taking back over.
Okay, awesome. And good news is I can now hear Chance, so we are good there. Okay, so before we go any further, I want to ask a question. We have different people in this room right now, and I'm curious what grade level you're associated with, what you teach, or what your specific position is. And then this session is called Integrating Math and Computer Science. So what made you want to attend this session specifically? You can either come off mute and say it to the whole group, or you can drop it in the chat, either one. But again, what grade level, what position you're in, what made you want to come to this session? Give you a few moments to do that. Okay, Jessica teaches ESL and elementary interventions, looking for some effective math interventions. I like that. Jackie is looking for ways to integrate computers with math concepts. Instructional designer. Yes, always good to have new ideas. I agree. Creative ideas. Love that you want to know more, Vanessa, about technology. I believe you've been in a few of my sessions in the past, if I recall, Vanessa. Okay, all very good reasons. We hope that you are able to take something from our session today and that you could use it in the classroom as soon as this week. So on your screen right now, you have a list of different sentences, a list of different statements. And I want you just to look at those for a moment and just kind of read those to yourself. Give you just a moment to do that. Okay, and right beside that box, another box is going to come up with some additional statements. I want you to read those now. Two different columns. As you're looking at these, I want you to think about the differences that you're noticing between these two columns. What do you notice? What do you wonder? So either in the chat, or you can come off mute to do so, either one will work. Which one of these columns do you think is computer science? Do you think it's column 1, the one on the left, or do you think it's column 2, the one on the right? Jessica says column 1. Christy says column 1. Jackie says column 1. Lori says column 1. Okay. So I'm seeing a whole lot of ones here, but my question to you now is why? What do you notice? What is the difference between column 1 and column 2? What stands out to you? Oh, Jessica, yes. The verbs. Yes, Lisa, as a science person, words like analyze. Absolutely. So yes, on the left-hand side, you have those scientific words. You have those verbs like analyzing and researching and evaluating and all those types of things. Kathleen mentions the levels of Bloom's. So remember, it's computer science. So the things on the right, a lot of that's just kind of plug and play type things. It doesn't take a lot of higher order thinking skills. You just kind of learn how to do it. Those are important things. Nobody's saying that they're not important, but that's just a part of learning about technology. Taking it to a whole nother level is what computer science is. Learning how to analyze with it, learning how to research, learning how to evaluate and create. And it goes beyond just kind of learning a subject area, but it's almost a way of thinking. And we're going to discover that a little bit more as we move on in this session. Next slide, please. So why? Why are we talking about computer science in an elementary session? Exposing students to computer science is something that builds lifelong learning skills. Let's face it, computer science is everywhere. We hear about artificial intelligence, AI, and we hear about all the changes, some of them really nice, some of them kind of scary, that's kind of predicted through it all. That's computer science. And it's important that our students learn both the benefits and the potential concerns of what's going to be affecting the rest of their life. And as they begin to delve into that, they're learning how to think critically. They're learning how to think creatively. They're learning how to collaborate. They're learning how to problem solve. Those are all important aspects. And beyond that, we have legislation that says that computer science must be taught or must be offered all elementary schools and all middle schools in this state. So it's a part of the legislation. So next slide, we'll take a look at how this legislation could be met, how to fulfill the requirements of it. There's 3 different pathways schools can take. First one is to offer a standalone computer science course. The second pathway is to offer computer science integrated into other courses. And then the third one is to offer computer science as a part of the special programming. So they may have school may have a STEM rotation or something like that, and they could include computer science in that. So a couple things I want you to think about. Number one, an elementary teacher teaching computer science doesn't necessarily mean that that elementary teacher needs to become a coding expert, okay? That's a big concern and big misconception of many elementary teachers who got into teaching without ever planning or thinking that they were going to one day be teaching computer science. And then I want you to think about these 3 ways to offer computer science. Thinking about the building that you're in, which one of these 3 ways seems most realistic, most achievable to you? You can put that answer either in the chat or you can come off mute. Thinking about these 3 pathways that are on your screen right now, which one of these seem most realistic or most achievable for your school building? So first one is a standalone course. Second one is integrating into like math, science, social studies, ELA. Third one is to have a specials rotation. Okay, Jessica's district has a STEM class, incorporates computer science. That's good. And every school district is different. Every school district has different needs. And so these are all viable options. Integrated with subject areas. Okay. You that are saying instruction that is integrated. So, you know, I don't know that there's a right or wrong, but I would say probably the best way is a combination of the 3. In the real world, subject areas don't exist as islands by themselves, right? And the more we can build connections with other subject areas, the more that learning becomes concrete for our kiddos, especially at those early grade levels. So how do we do that though? How can we integrate computer science with math? How can we do it with science and so forth? The next slide, we take a look at that. On your screen, you have a bridge. Purpose of a bridge is to connect 2 things, right? To make a connection. On the one side of the bridge, you have your content area. You have math, you have ELA, you have science. On the other side of the bridge, you have computer science. How do we make that meaningful connection that is authentic to students without making educators feel like, oh, great, here's just one more thing that I have to add or that I have to figure out what to do? What is that bridge exactly? The answer to that question is computational thinking. Computational thinking exists throughout every part of your school day, and it is the bridge that brings your subject areas and computer science together. The next slide, we're looking at the ingredients of computational thinking. There's 4 main ingredients to it. There's algorithms, pattern recognition, decomposition, and abstraction. Your students are doing algorithms or step-by-step instructions all day, every day. There's patterns around them. We want our students to learn how to break big problems down into smaller, more manageable parts. That's decomposition. And then abstraction. They do that all the time in math, removing some of those unnecessary details, focusing on the things that are most important. Chance is going to show us some ways to incorporate computer science and math.
So now we're going to explore connections, specifically as it relates to our standards and objectives in both math and computer science. So first, I just want to engage us in an exploration phase of a few different grade levels and how those connections can truly be made. One way to emphasize these connections is really to start with your core content standard, in this case, mathematics. So let's begin by exploring our kindergarten algebraic reasoning standard 1, objective 2, which states that we want students to be able to recognize, duplicate, complete, and extend patterns. In the chat, what I'm going to do is I'm going to share our computer science framework. Of course, our Oklahoma frameworks for each content area allow you to explore each of the standards and the objectives for each subject area. Computer science, due to Jeremy's hard work over the most recent years, has been launched. So I encourage you to explore that framework, those objectives for kindergarten, and maybe identify one or more objectives that you think connect to this student learning outcome that we desire of kids in mathematics to recognize, duplicate, complete, and extend patterns. So I'll give you, let's say, 2 minutes to explore our computer science objectives found in those frameworks and identify one that you think might be a meaningful connection to be made. I encourage, as you explore those computer science frameworks and those learning objectives found within kindergarten, share one that you think might be able to make that connection to the recognition, duplication, completion, and extension of patterns in mathematics. Share that in the chat. Excellent. We're already seeing some similarities in an objective found that's focused on, with guidance, draw conclusions based on pictographs, real object graphs, or patterns. So hopefully kindergarten students are still able to utilize maybe a pictograph set of images to review that data and maybe realize what might come next. Excellent. And that is what we identified as well. We see that pattern connection being made in computer science practices and with computational thinking being addressed, even just within that math objective. So there's a really meaningful connection made even at those early stages of learning. So you might consider things that you could engage kids in doing to be able to engage students in this learning. So you might work with a classroom of students to build a class pictograph using a repeating pattern. I noticed in our standards, we don't necessarily address the specific styles of patterns that we expect students to master at these young grade levels. However, it might be a meaningful practice for a district to adopt that all students in kindergarten learn those AB patterns, the AAB patterns, ABC, and maybe if you want to continue to extend that learning, you can address ABCD patterns, AABB patterns. So in the nature of shapes, you see that as circle, square for AB style patterns, and circle, circle, square for AAB patterns, and so on. You might have students engage in the extension and completion of those patterns to finish that graph that you're building. Use the finished graph to answer and draw conclusions from maybe essential questions that you ask the student body. What item is addressed the most in that data set? What item is addressed the least in that data set? And being able to justify and explain why that is the case. And we know that pattern accuracy equals valid conclusions. So if a pattern actually breaks, our data claim or our justification may no longer be accurate. So we want to ensure that accuracy exists for valid conclusions to be derived. So you might consider what a teacher can do. So a teacher might lead a quick class vote and start a pictograph using linking cubes or counting bears in an AB pattern. Students would place those, complete, and extend those patterns to finish the graph. Then the students use the finished pictograph to say more, less, or same. Use those essential language usage that's grade level appropriate to explain how they know that the pattern is correct and that their conclusion of what may come next is also correct. So let's explore something in grade 3. In grade 3, we're going to adjust a data objective in the area of mathematics, where it's grade 3's data objective standard 1, objective 2, where it states that we want students to be able to solve 1- and 2-step problems using categorical data represented with a frequency table, pictograph, or bar graph with scaled intervals. So I encourage you to go back into the Oklahoma computer science frameworks and take about 2 minutes again to discover the computer science objectives in grade 3 that might most reasonably connect to this data objective you see on the screen. Excellent. Thank you guys for sharing in the chat. I just got back to see that music connection that was made by Elizabeth. I appreciate you sharing that because there is a cross-curricular connection of seeing patterns in music and being able to apply those patterns. So we really don't oftentimes think about music teachers Sorry, that was my alarm to come back with you guys, but seeing music teachers engage in the area of mathematics, but they truly do as it relates to standards that they're also addressing in their learning. I see similar sentiments shared, but several different objectives being connected to this math objective in the area of grade 3. We see that computer science has an objective that addresses the collection and organization of data in various visual formats that are addressed in this data objective in grade 3, as well as the utilization of data to make predictions and discuss whether there's adequate data to make reliable predictions. So really the justification and the reasoning of that is really essential in both computer science and the area of mathematics. But also Lisa shared the decomposition or breakdown of the steps that are needed to solve a problem into a precise sequence of instructions. For two-part math problems especially. I think that that objective specifically can be connected to so many of our math objectives. We really want students always breaking down the information that they see to really make sense and problem solve in a meaningful way. So I appreciate you all for sharing. The connection that we made was to the computer science standard that was originally shared by Jessica. Excellent. Thank you for sharing that. That collection and organization of data in various ways. So now we're going to sequence to grade 5 because I know that we have some possibly some educators that teach later, or we're not going to move to grade 5 yet, I'm sorry. So we're going to discuss that connection and how we can actually apply that connection of those standards in both computer science and mathematics in grades 3. So consider how a class might conduct a favorite color survey in that grade level, collecting that data initially. Students are able to engage in that collection of data and actually tally those results, maybe into something like a frequency table, or maybe in a variety of or various different ways outside of the frequency table. Now to move to representing that data as a pictograph or maybe a bar graph. And then they can actually apply that data to solve those 1 or 2-step real world problems, actually utilizing that display or those sets of displays that they've created over time. Now students would eventually be able to revise the display, maybe with scales of different scales or labels to draw additional conclusions that might better make them interpret the data in a way in which they need to solve a different or unique problem. So consider this, students might take a quick favorite color survey, tally those results in a frequency table, create the pictograph or bar graph with the scaled intervals. Then they can actually move forward with that class display to solve 2-step problems. Maybe you consider asking or posing those questions for exploration of how many more blue than red exist in the data set, or how many chose blue and green altogether. Really engaging students in a variety of ways to interpret and analyze that data set that they've created. Now we can move in sequence towards a connection as late as grade 5 being made between computer science and math. I'll give you another 2-minute period to explore those computer science frameworks, but this time looking for connection in grade 5's algebraic reasoning objective 2 within the initial standard. So use a rule or table to represent ordered pairs of whole numbers and graph these ordered pairs on a coordinate plane, identifying the origin and axes in relation to the coordinates. So explore and continue to share in the chat. Excellent. Thank you for sharing, Jessica. Jessica identified a computer science objective that addresses the selection and use the most efficient computing systems to perform a variety of tasks for an intended outcome while recognizing that users have different needs for the technology they might use. The connection that we made was a little different. I see another connection that came through by Lisa. Thank you for sharing, creating programs using a programming language that utilizes sequencing, repetition, conditionals, event handlers, and variables using those math operations. Excellent. And one that we still connected to was the organization and presentation of collected data to highlight comparisons and support claims. So really, I guess it would vary by the experience that you're engaging students in. So let's engage in what kind of experience that could be made as it relates to the objective that is focused on organizing and presenting collected data to highlight comparisons and support a claim made. So maybe you consider having students collect two variable data sets, maybe the minutes they read versus the quantity of pages they actually read. Students would then maybe engage in the organization of that data in a table of ordered pairs. Students then graphing those ordered pair sets on a coordinate plane, labeling the axes and identifying the origin, and then using the graph to actually compare and support a claim. Maybe they identify trends that they notice or outliers that are of significance that need to be considered. We know that graph accuracy actually allows students to engage in creating accurate claims or using reasonable justifications when supporting an argument that they're making. Wrong axes actually maybe foster students an opportunity to draw an incorrect conclusion. And I think in the area of mathematics, we always want students to be able to visualize data or visualize a problem in which they're solving and trying to overcome. And computer science really allows students to engage in that practice in a way that's real world applicable. So students collect the data, they organize it, they graph it on that plane, and then they can graph to support the claim that they've made. If the pairs or axes are wrong, the claim that they made actually just falls apart. So this is an example of that. When students actually engage in that data collection, maybe use computer science principles to build this visualization out, they're able to notice and identify outliers that exist. Maybe that skews average data. And once students have the capacity to begin exploring that, that's another huge connection that can be made. I'll turn this back over to Jeremy.
Okay, very good, Chance. Thank you. And it was very refreshing to me as the project director of computer science to see your input in the chat and to see you making connections. And before we even move on to these slides, I am curious, what stood out to you as you were actually going through some of those computer science objectives and thinking about a connection to a specific math standard? What are some things that stood out to you? You can come off mute or put that in the chat. Lisa said she loved the social studies ideas from Brenda. I liked the pattern recognition that Elizabeth put in. Christy is saying it shows students how math is relatable to the real world. Okay, we'll come back to this thought in just a moment. On your screen right now, you have math and computer science thoughts. So writing algorithms for math procedures, debugging, creating variable expressions to represent word problems, collect and visualize classroom data. I want you to think back toward the beginning of this presentation. And we talked about that bridge, right? We talked about the connecting piece that connects computer science and your other subject areas. And we said that that bridge or that connecting piece is computational thinking. And then we talked about what the 4 ingredients of computational thinking are. And right here in these math concepts, in all the ones that Chance used as an example, and in these right here, computational thinking is embedded within them. Algorithms was one of those ingredients, and there's algorithms throughout math procedures. And you know, how many times do students get math problems wrong? What happens when they identify that? And when they begin to try to problem solve and figure out, well, what happened when they debug or they decompose that problem into more manageable steps? It's part of decomposition, one of the 4 ingredients. And then data representation, creating variable expressions to represent word problems, another one of those. And then the visualization. All of these things are the ingredients to the computational thinking. So we've talked about a lot. We've showed you several examples, but we are living in 2026 and we want your job to be as easy as possible. And thankfully, there's some resources that are coming out here and there that does make our jobs a little bit easier, that we can use kind of as a thought partner, kind of as a collaborator with us as we think, okay, what is the best way that we can present to our students? What is the way that we can give them the highest possible quality of education? And when you're trying to think, okay, I have this subject area, whether it's math or science or English, and you're wondering, I want to delve into computer science, but I want to do it meaningfully, and I want to do it in a truly authentic way, in a way where it's truly integrated, where not one subject is highlighted more than the other, but they are so much coexisting that they are together. If you took one of those aspects out, the lesson would no longer stand. Using your favorite generative AI can be a very big benefit to you. And so you can put in a prompt where you're telling that generative AI, such as ChatGPT, Gemini, and so forth, what grade level you're working with. You can attach standards, the Oklahoma Academic Standards, to it. You can let it know the different constraints that you have, whether it's time or whether it's a classroom setting. For example, maybe your classroom, you don't have a whole lot of technology. Or maybe you feel like your students have had enough technology for the day, but you still want them to learn computer science. And so you're trying to find ideas to teach them computer science and integrate that within other subjects without getting them on screens. And so those are all things you can tell the generative AI. And then you can ask it for an authentic integrated math or whatever the subject may be, but tied into computer science. And so I want to show you an example because I did just that. Chance, do you mind? Could you click on that bit.ly link? Again, we will share these slides out, and that is a QR code. Will take you to the example I'm going to show you, as well as that bit.ly link. So this is an example that I did. And up there, I was not trying to be perfect. I was purposely kind of being a little bit rough, but I was trying to be specific enough where it produced what I was asking for it to produce. So this is what I put into my favorite generative AI. I said the attached document is a computer science standards document. So I went to the standards on the website, and I downloaded specifically the computer science standards, and I attached it to this generative AI. And then I said, the following is a 3rd grade math standard. And I put in a math standard that I thought, I wonder if this would go well with a computer science standard. Okay. And you can read that there. That is a current Oklahoma Academic Standard for Math 3.N.1.3. And I pasted that in there. And I told it to find a third grade computer science standard and to create an authentically integrated lesson that can be taught in one class period for a classroom that does not have technology. Now, I don't know about you, but if somebody dumps all that on me at once, it's probably going to take me a little bit to really get it down. But I put it in there. And what it produced, I'm not going to go over the entire lesson, but I'm going to point out some highlights in it. The students work with that math lesson, and they're using mental math to find 100, 1,000, and 10,000 more or less than a given number. And instead of just kind of working the problem and getting answers, the students work in small groups and they create step-by-step instructions, which are what? Those are algorithms for how to do this efficiently using place value. They test those instructions, they put in new numbers, they see what's working, what's not, they revise the instructions when something doesn't work, breaking down those things into smaller, more manageable pieces, and then they explain why the process works. There's not any technology involved. There could be, you could adapt it very easily to involve technology, but there's not in this lesson. And students are thinking the same way a computer would. They're breaking those problems into steps. They're focusing on the digits that matter, removing some of the less important items, and they're improving their solution. So as we look through here, I'm going to point out some of the highlighted areas. Down, keep scrolling, Chance, if you don't mind. Yeah, right there. No, I'm sorry, scroll back up towards the top. I think it's page 7 is what it will show. You're on 12, so up towards the top some more. Okay, perfect. So it provided here the learning objectives. So using mental place values, strategies, and so forth, design, follow, and refine an algorithm, and then identifying patterns and how digits change. And then it even tells you, as you look down there, what materials you need. So no technology, but to give them some manipulatives, some hands-on, doing some number cards, a place value chart, specifically naming some index cards or even paper as algorithm cards. It gives a lesson flow, includes a hook, introducing, the teacher kind of showing what to do, student activity, along all the way down to an exit ticket there on page number 9. And then talking about why this is authentically integrated. And that's a whole nother session talking about what strong, true integration looks like. We're not going to get into all of that. There's different, you can almost say it's a spectrum, if you will, and there's different levels of that and so forth. But it gives you also some optional computer science language to throw in to all of that. So you have access to this. The bit.ly link is in the slide deck as well as a QR code. I would encourage you to take a look at that as you can. And then we will continue with the slide deck. Next slide, please. Okay. So again, we have talked about so many different things in today's session, and it's 4:45. We've gone through a lot. I want you to think right now about the barriers you see. What do you think is hindering you from teaching computer science and math, or music, or PE, social studies, any other subject area? What do you think would be hindering you from teaching it in an integrated way? You can put your responses in the chat there.
I know others might not share, but I would share, from a perspective as an educator, I think that I just oftentimes didn't know what I didn't know, but I also was apprehensive to engage students in experiences for discovery. And I encourage all educators to really strive to engage students in that practice. I think Christy highlighted the real world application connections that can be made in this process, and there's opportunity there, but it is a challenge. Um, and we recognize
You
it's
know, I was
challenges.
going to say that I think one of the great things or the big concern or struggle teachers may have is understanding the computer science standards. And I'm thinking that maybe you could even take a computer science standard that was confusing and have AI help unpack it and explain that.
It's a great idea. And you do have a couple resources available to help with that, because that is something, especially, my heart goes out to educators. I love working with elementary teachers. I am very aware that many, never thought that they would be teaching computer science. And so some of those standards, they look at that and they're thinking, how do I even understand this? The framework, which Chance has been having you go to, does break down those standards into what they are, including student actions and teacher actions and some key concepts and some misconceptions and all of that. And then in addition to that, using your favorite AI and taking that standard and kind of like we did with the lesson plan, but saying unpack this standard. And you can even say it something along the lines so that maybe a 9th grade student or a 6th grade student or a 4th grade student to understand, whatever it takes to help you feel confident that you know what that standard is talking about. It's very good. And then one more question for you. After attending this session today and seeing the examples that Chance had, getting into the computer science framework, noting that the bridge is computational thinking, which is really a part of everything you teach. How do you feel about integrating computer science, not just into math, but into anything? Do you feel happy? Like, yes, this is something I'm happy about. We can do this. Do you feel some anxiety there? Like, oh my gosh, this is very overwhelming. Or do you feel stressed? Oh, it's just something that, I can't even think about right now. Or do you feel excited? Like, yes, I can't believe that we finally get the opportunity to do this. So if you could just put in the chat, that would be great. Happy, anxious, stressed, or excited. If you put anxious or stressed, you will not get your PD certificate. No, I'm just kidding. That's not true. This is being recorded, so I can't say that. We do want to know how you feel. Happy. Great. And so here's what I would say to you. I'm glad that you feel like you're making progress. For those who do feel happy, for those who do feel excited, if you get great ideas of something that's working, send that to me. Let me know what you're doing. Give me the opportunity to celebrate that with you. I would love that. And then Kelly, is being very honest. I'm still anxious. I'm still stressed. And that is perfectly understandable. Perfectly understandable. And that's one reason why I want you to take my email down. Give me the opportunity to collaborate with you. If you have a lesson you're teaching and you just say, hey, Jeremy, I want to know how computer science could tie into this. I'm happy to be a thought partner with you on that. Are there any questions at this point? Jackie, it's thinking outside the box. Yes. And remember at the beginning, we mentioned computer science isn't just like a subject area. It's kind of a way of thinking. So I'm not saying anxious, but would love to see this in practice.
I want to add to Jackie, for me to see it in practice, I think the first time I did algorithms with like 5th graders and we were talking about space and I was having the students try, like they couldn't see their partner, their partner was trying to get from one coordinate to another in the classroom. And so the student sitting facing away from the situation and is just looking at a map and trying to give the other student directions, that really solidified things for the kids. But then like trying to work with kindergarten teachers, and it's, you know, just my 4-year-old, you know, how do you go from the couch to the bedroom? Like what steps do you take? Or from the train table to the toy box? There's even children's books about that kind of stuff. So like not being afraid to think about those in a much smaller capacity than we like give computer science. We're always, it's for really smart people. It's something not for me, but it really is hands-on, and we talk about those things all the time with our kids, just not realizing the terminology that goes with it.
Awesome. Thank you, Lisa. And, you know, I will use this as an opportunity to put a plug in for some of the sessions that I do in our annual conferences that we have, Oklahoma Inspire. I always do an elementary session that helps to show what this looks like in practice. And then during our fall regionals, and we are generally all over the state, so that it's never too far of a drive to get to where we are presenting. So watch for communication to go out in regard to both of those. And I would love to have you join. Other educators come, some that are doing computer science and feel great, others that aren't. It's just great to get everybody together and learning from each other in those sessions. Okay. Any questions? All right. If not, if you don't mind, before leaving the Zoom meeting today, completing the survey for us. The name of the session is Integrating Math and Computer Science. I think the way it's set up, you will have to probably choose either math or computer science. Either one is fine. We'll still get the data. You can use your phone to scan the QR code, or you can enter that bit.ly link down at the bottom. And after that, that concludes our session. We thank you so much for being here today.